How's it going, you guys? My friends. In this video, we're going to be talking about a couple of things. One of those things is graphing the square root function. We talked about this very first day of school, very first day of Algebra 2. If you don't remember, I'm going to refresh your memories. And then we're also going to talk about graphing inverse functions. So we'll get there. So for this first part, just graphing your square root function. Just to remind you guys, so like if we have the square root of x, the square root of 0, that's just 0. The square root of 1, that's just 1. Square root of 4 is 2. Square root of 9 is 3. So when x is 0, y is 0, so I have a point at 0, 0. When x is 1, y is 1, so I have a point at 1, 1. When x is 4, y is 2, so 1, 2, 3, 4, 2. And when x is 9, y is 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3. So it'd be somewhere out there. So your square root function, if we kind of connect the dots, just looks something like that, which is almost like a sideways parabola. Ooh, but it's kind of missing like the other half of it. Right? Whoa, now it does look like a parabola. All right, well, we'll get there. We'll get there. But just in the red here, just in the red there, that is the parent function of the square root of x. Now we're going to look at what kind of how we can change how the graph looks. So first thing I'm going to show you guys is we have f of x equals 2 times the square root of x. So what I usually do, and in my graph here, I have the parent function points already on here, same points that we have from here. So I know square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. What this 2 affects, since it is not with the x, I say that this multiplies our y values by what we see, which would be 2. So we would be multiplying the y's by 2. So if we go through that, the y value of this point right here is 0. 0 times 2 is 0. So that stays right where it is. Y value of this point is 1. 1 times 2 is 2. The y value of this point is 2. 2 times 2 is 4. So what happens is this is called a vertical stretch. It stretches it in the y direction by a factor of 2. You're multiplying your function by 2. So it's like you're multiplying the y values by 2. It's called a vertical stretch by 2. All right, same idea, except here, it's like I'm multiplying my y's by -1. So what that does is that is going to, well, just let's take a look, see what it does. Y value here is 0. 0 times -1 is still 0. 1 times -1 is -1. 2 times -1 is -2. So what this does is it flips it or reflects it over the x-axis. It still has the same vertical distance. This is still 2 units away and 2 units away, except it is reflected over the x-axis because it's like we flipped it on the x-axis in order to make our graph. So we have multiplied the y's by -1. Well, what if we have a factor of 1/2 on the outside? Well, exactly kind of like what we've been seeing, except we're going to multiply the y values by 1/2. So 0 times anything is still 0, so that point will still stay there. 1 times 1/2 is 1/2. 2 times 1/2 is 1. So this is a vertical shrink by a factor of 1/2. It kind of squishes our function down. All right, next type of thing that you will see. You did this in the very first week. You guys have had some practice with this. We talked a lot about this. Since this is, again, not with the x, it changes in the y direction. This +1, all it does is it takes all of your points and moves them up 1. So we are up 1 from all of our points, and we will graph our function just as if it was moved up 1. And remember, when we are with our x, it will change in the x direction, but we do the opposite operation of what we see. So right now we see x is +1. Instead of moving to the +1 in the positive direction, we do the opposite of what we see when we are with our x. So we need to take everything and move it to the left one. So left 1, and boom, there's our function. If I saw a function that said f of x equals the square root of x minus 3, that would move to the right 3. So right 3, and you could move every point on your parent function to the right 3. So notice, super, super important. As long as you guys have your parent points here, it makes it a lot easier to work with these things. All right, moving forward. You guys are doing awesome. we have the square root of 2x. So notice now I'm multiplying my x's by 2. Like I said, when we're with our x's, it's going to change in the x direction. So it's going to change in the x direction. It's either going to stretch it out or shrink it. Right now what's happening is this is 2 times x. But like I said, just like when we were doing plus or minus, we do the opposite operation. So instead of multiplying my x's by 2, I am going to divide all of my x's by 2 and do half of my x values. This is called a horizontal shrink. So it's changing in the horizontal direction. So I have 0, 0. My x value here is 1. Half of 1 is 1/2. My x value here is 4. Half of 4 is 2. So it almost looks the exact same as a vertical stretch, except it's not. It is shrinking in the x direction, so it's like I'm squishing my function in towards the y-axis. Just the opposite thing. Again, I have my parent points here. Again, super, super important. I can't stress that enough to you guys. Right now, it's happening inside with the x. My x's are being divided by 2. Remember, opposite operation when you're with the x's, so instead of dividing our x's by 2, we are going to multiply my x's by 2. So x value 0 will stay there because 0 times 2 is 0. X value of 1 is 2, so 1 times 2 is 2, so that will move here. 4 times 2 is 8, so that moves all the way out there. So this stretches it in the x direction. This is a horizontal stretch. All right, last type of thing that you will see. If we are multiplying our x's by -1, it's the same thing as dividing our x's by -1. So if I take my x value here, the x value is 0. 0 divided by -1 is still 0. 1 divided by -1 is -1, believe it or not. 4 divided by -1 is -4. So that will move to 1, 2, 3, 4. So keep the same y value. So what happens is it stretches, reflects it over the y-axis. It's like a perfect mirror image from your parent function over the y-axis. So notice, negative with the x, it reflects it over the y-axis. When we had a negative with our y, it actually reflects it over the x-axis. All right. Oh no, I didn't put my parent points. I done messed up, man. But what I wanted to stress to you guys in this one is that you can do multiple things in the same equation. You will probably be doing that more often than not. So just like PEMDAS we multiply and divide before we add and subtract. This 2, since it's multiplying right now, it's going to divide my x's by 1/2. So x is by 1/2. That -4 on the outside, that is going to move everything down 4. Because remember, it moves in the y direction. If it's not with the x, it moves in the y direction. The only way it would be in the x is if this square root would have continued and it would have been over the -4. So first things first, we need to multiply and divide. So here I have a division. X is by 1/2. So the x value is 1. By 1/2 is 1/2. 4 by 1/2 is 2. So just after multiplying my x's by 1/2, I have an image something like this. Now I need to take everything and move it down 4, and that will actually be my final equation. So I have down 1, 2, 3, 4, down 1, 2, 3, 4, and down 1, 2, 3, 4. This is the graph I'm looking at. As you guys do your test quizzes, anything like that, make sure I know which one is your final graph if you are putting multiple on the same grid. All right, I'm going to take a break real quick and get up my next thing set up. Y'all are doing awesome. Okie day. Next thing we're going to look at is inverse functions. So just a reminder, to find the inverse, you guys have had to do this before, I promise. You even had to prove it, that f of g of x equals x and g of f of x equals x. So to find the inverse, just to find it, switch the x and y exactly where they are in the equation and resolve your equation for y. So here's the first problem we're going to look at. Write the inverse of each function and restrict its domain. So what that means, first let's tackle this one at a time. Write the inverse of the function. So for this function, don't forget f of x is kind of like our y. So if I switch x and y exactly where they are in the equation, don't change anything else about it, this is my new equation. So notice, y became x, x squared became y squared. So now in order to resolve this thing for y, it's just like when you were solving square roots. I can subtract 7 to the other side, such that this becomes x minus 7 equals y squared. And then in order to get rid of that squared, I can take the square root of both sides, such that I have y equals plus or minus the square root of x minus 7. So don't forget, whenever you take the square root, you gots to have that plus or minus. It could be either or. So this is f inverse, so f to the negative 1 of x equals plus or minus the square root of x minus 7. All right, so now looking at the images of these things, if I graph x squared plus 7, x squared plus 7 looks like 1, 2, 3, 4, 5, 6, 7, a parabola moved up 7. All right, there's x squared plus 7. If I graph plus or minus the square root of x minus 7, that is a square root function, what we were just talking about, of move to the right 7. So 1, 2, 3, 4, 5, 6, 7. I have the positive direction. I also have the negative, because remember, if we had the negative y's, it would flip it over the x-axis. So these graphs, they're inverses of each other because they reflect over the line y equals x as well. If I folded it right on this line, it's like this would mirror and it would match right onto that, or vice versa. This would match right onto that. It's a complete reflection over the line y equals x. So what that also means is if I have the point 7, 0, then I also have the point 0, 7. And all of the points will do this because with our inverse, we switch the x and the y. So the x was 7, the y was 0. Now the x is 0 and the y is 7. We switch the x and y exactly where they are. That is why they are inverse functions. All right, let's go a little bit faster. A little bit faster for the master. So 2x squared is a parabola that is stretched vertically by 2, so that would look something like that. In order to find the inverse, switch the x and y exactly where they are, so x equals 2y squared. So here, I need to divide by 2 first, divide by 2, so I have x over 2 equals y squared. Take the square root of both sides, and don't forget to add that plus or minus. So we have f inverse of x equals plus or minus the square root of x over 2. So that is a square root that has been stretched in the x direction by 2, so it would look something like that. And we would have where the y's are negative as well. So you can see here too that it is a reflection over the line y equals x. They are reflected over that line. All right, now with this one, here we're starting with the square root, so it requires just a little bit more work. If we graph this, this is a square root that has been moved to the left 2. Come on, pen. Keep up, pen. Right, pen. Come on, man. Come on. So that would look something, if this pen will write, like that. All right, so now, same thing. To find the inverse function, we need to switch the x and y where it is. So I have x equals the square root of y plus 2. Now in order to get rid of the square root, like you learned in solving square root functions, we need to square both sides. So we have x squared equals y plus 2. And then you can subtract the 2 to the other side such that we have f inverse of x equals x squared minus 2. So now that is a parabola moved down 2. If I draw the entire parabola, my entire parabola moved down 2 would look something like that. But notice, this function is only like half of a parabola. So here is a part where we need to actually restrict the domain. So what that means, if I were to graph this down 2, in order for it to reflect across the line y equals x, I can only have that part of the function. Because here, I only have the positive part of the function. So what I need to do is I need to get rid of anything that was on the left-hand side, or the negative kind of side of that parabola. So I need to take my domain of this function only when x is greater than or equal to 0. That is restricting the domain, so here's finding the inverse, and restricting the domain is that part. We're only taking half of our parabola. Let's see another one where we do it again. So we have f of x equals 2 times the square root of x minus 1. So we are multiplying the y's by 2 and moving it to the right 1. So we would have something like that. So notice again, I only have the positive side of the parabola. I only want the positive side such that it will reflect over the line, something like that. So my guess is I can figure out the equation of the parabola just knowing that it reflects over the line y equals x, even though I drew that wrong because it should be up here. I'm so sorry. I'm so sorry. But you can work it out with the equation. It'll make more sense. So if we have x equals 2 times the square root of y minus 1. Now I need to get y by itself. So the first thing we need to do is get rid of that 2 in front of my square root. So if I divide by 2 and divide by 2, I have x over 2 equals the square root of y minus 1. In order to get rid of that square root, we can square both sides. Square. So I have x squared over 4 equals y minus 1. Now rewrite that using inverse notation. And I have f inverse of x equals x squared over 4, and add the 1 to the other side so that we have y by itself, so plus 1. All right, so now if I were to graph this thing, my y's are being divided by 4. I have moved up 1, so divided by 4 and moved up 1. So notice we only want the positive part of that parabola. So x needs to be greater than or equal to 0. Lucky day. Last one. You guys are doing so good. All right, so we can switch the x and the y. Find the inverse equals square root y plus 2. Square root of x plus 2 will look something like this. So hopefully our inverse would look something like this. So I can subtract the 2 to the other side. So x minus 2 equals square root of y. Square both sides, square, square. So you can leave this for us as just x minus 2 squared. You don't actually have to multiply everything out unless you really, really want to. So f inverse of x equals x minus 2 squared. So now here, for restricting the domain, notice that our vertex happens at 2, 0, because this was a parabola moved to the right too. So we need to say x is greater than or equal to 2, such that I only take this half of the parabola. If I put the other half on there, it no longer makes it an inverse because our true function was only the square root moved up 2. All right. Hopefully this video was helpful for you guys. Take a look at that worksheet. Do everything you can. Come talk to me in class. I'm here for you guys. Love you guys. And I will see y'all soon. Bye.